Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born, the first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
Hi everyone, welcome to another DSPT webinar. So this is our seminar number 95, and today we'll have Bruno, who is going to talk to us about how to tackle interconnected bypass fraud. And so let's start with the agenda for today. So we'll start with some introductions and I will tell you a bit about the DSPT. Then I will pass the word to Bruno. And then, of course, by the end of Bruno's talk, we'll have time for Q&A, and then you're all invited to join us in our networking session. So for those of you who are new to the DSPT, or for the old faces that we usually see around here, so Data Science Portugal is an informal community of data science enthusiasts, and our main purpose is sharing of knowledge and experience across different fields related to data science, machine learning, and AI. So we've been organizing mostly meetups, and so today is we've organized more than 75 meetups, and today is actually our event number 95. So what's our philosophy and what we stand for? So we promote knowledge sharing, we organize open events, and we are really focused on breaking the barrier between speakers and audiences. And we have a really strong focus on promoting network between data scientists. So we really don't care about bullshit, people trying to sell shameless promotion and trying to use the DSPT as a stage. And so this is what we usually look for. So as always, we are open for proposals. So if you have interesting work that you want to share with the community, or if you have an interesting topic that you want to propose, please feel free to do so and use this link to do so. And so we are going to resume our physical meetups very soon. So stay tuned to our social network and our agenda. And as you probably already know, we have physical presence in these 5 cities. So Aveiro, Braga, Coimbra, Lisboa, and Porto. So please try to find us and try to join us for our comeback after the pandemic webinar pause.
This is our current site, Data Science Portugal, where you can find the job offers and events about data science. And you can join us in our social network, like Hannah said, Meetup, LinkedIn, Slack, and so much others. For the Q&A, please don't forget to do the question in YouTube chat, and we will try to respond to them. So regarding our speaker is Bruno Veloso, and what you can see is assistant professor at University of Portucalense, and is invited assistant professor at the University of Porto. Hi, Bruno.
Hello, everyone.
And the stage is yours.
Okay, thank you so much, Mafalda. First of all, I want to thank you, DSPT, for this opportunity to present the work that we are doing on Atelier, which is a center in Hashtag. I'm, like Mafalda told us, I'm an assistant professor at University Portucalense, and I'm also invited assistant professor at FEP. at master. So the topic for today is how to tackle interconnect bypass fraud, which is, from my perspective, a very interesting topic. Why? Because you can earn a lot of money trying to catch the fraudsters, or if you prefer, you can do the frauds by yourself, of course, and earn some money from the clients. So I prepared the presentation in 4 key topics. The first one is the problem definition. I will try to explain a little bit how these kind of frauds can be made using some technology, some algorithms. Then I will present some techniques that can be useful to try to catch these kind of frauds or catch these fraudsters. And at the third point, I will show you some experimental work that we did in collaboration with WeDo Technologies that was bought by Mobilium, which is a North American company. And finally, I will draw some conclusions about our work. But let me add something. This work is not only made by me. I have several colleagues. Shazia Tapsun is one friend that works on this field. Another is a very well-known person, João Gama, which is a kind of a mentor for me. And so let's try talking about the problem by itself. Do you know that telecommunication world is very big nowadays? We have a lot of persons connected using 5G networks, which is the new standard nowadays. And we can define fraud on this field like an abusive usage of network and services without the intention to pay to the networks. So according with a global fraud loss survey presented on 2021, these frauds can provoke a kind of 39 billion American dollars on losses annually on these telecom sectors. And the main type of frauds is the interconnect bypass fraud. This kind of fraud is very common. It provokes a lot of losses on these companies, and these companies are paying several thousands of dollars to improve their security mechanisms to capture this type of frauds. So in this slide, I prepared a small picture, which is also provided by WeDo Technologies, explaining what is the interconnect bypass fraud. So let's say that we are on the country A. So we want to do a call for a specific country C, presented on the right side of the slide. And of course, we have several countries between the country A and country C. Usually, or the normal way of following or forwarding our calls is at the gateway of the country A, we are giving the calls for the gateway of country B. But on this type of frauds, several persons creates a kind of a virtual network. And these virtual networks typically pick all the calls that we are or we have at the gateway of the country A, and they are using a kind of VoIP network to send all the calls for the destination country, like country C. You can imagine this strategy like if you are making a call from India to United Kingdom, you can make some call, a virtual provider pick your call, insert this call on the VoIP network like Skype or a different one, and at the destination country, which is the United Kingdom, we pick this call from the VoIP network and we can make an internal call on the country. So we are picking the money of this international rate between country A and country C, which is in this case India and United Kingdom. So the fraudsters are keeping the money of these intermediate countries like country B or others. So we need to analyze in some way the patterns that we have on these gateways. Let's go back. So we need to explore how the data is generated at the gateway of country A and country C to try to detect different or strange behaviors on the patterns of the calls. But of course, you can imagine that during the time, or we can observe a kind of evolving on this type of frauds with new strategies to simulate normal users, avoiding this type of capturing frauds algorithms like we did on this work. They use more advanced hardware to have more SIM cards to make the calls on destination countries, and they can also manipulate some identifiers of the calls, and they can vary a little bit the rate or the number of calls that can make per day for a specific SIM card. So usually, or nowadays, the most current approaches to capture these type of frauds are using blacklists. But blacklists are not very powerful. They are very inefficient in detecting new frauds, and they are also inefficient to detect changes in the patterns. I will show you in a couple of slides a short video showing that we have different patterns occurring during the time. So it's not possible to use blacklists as the single strategy to stop this kind of fraud. So our approach is based on data-driven, and our goal is to have an algorithm that can work in real time. So we are looking at first point, the high asymmetry of international termination rates. So these calls between countries, between India and the United Kingdom. And of course, we want to see some strange behaviors on the calls that we call abnormal behaviors. And we have four main types of abnormal behaviors. The first one is the burst of calls, which can be characterized like a huge amount of calls made by a SIM card or a client. The second one is calling a large set of numbers. We have a case on this work that a specific guy on Russia is calling 6,000 numbers on Europe. So it's very strange. One single person has 6,000 different friends dispersed by the European country. The third point, or the third type of abnormal behaviors, is the repetition. Maybe you are trying to think, okay, repetition, we can have the same pattern of calls during a period of time. So we can make, for example, 500 calls this week, and we can stop a little bit to avoid these detection mechanisms that we have. And next week, we can make another batch of 500 calls. And the last is the most, in my opinion, of course, the most advanced method, which I call mirror. So they can divide this amount of calls by multiple numbers. They have a kind of a SIM farm, which is a device composed by a lot of SIM cards, and they can split the amount of calls per SIM card, avoiding the huge burst of calls or trying to avoid the repetition. So can you move to the video, dear? Okay, thank you. So in this video, we tried, our first approach is to look our data in a dynamic way. We have data from a specific telecom company, and we can see on this video that all the dots are clients. The colors represent the country code of these callers, and the wires are the connections or the calls between clients. So we can see here that in some cases we have clients that are making a huge amount of calls. For example, this amount of calls here in blue, and we have different countries connected by maybe some gateways. These type of machine learning techniques, like social network analysis, can be very useful to detect which are the most important node on the network, the weakest node on the network, and so on. So is a possible solution to deal with these kind of problems, these interconnect bypass fraud problems. But we decided that is not very useful for us because in real life we have millions of calls, and these kind of algorithms are not very scalable when compared with the solution that we have. So we moved from the social network analysis to a different kind of strategy. So, can you change to again to the presentation? Okay, thank you. So we want to detect in real time and as soon as possible these possible fraudsters, or these numbers that have a kind of abnormal behavior. At first stage, we decided to use a kind of frequent items algorithms, which we have the heavy eaters. Basically, we try to provide an approximation of the counting of the frequent items on the data that we are reading. And the second one is the hierarchical heavy eaters. So basically, we have a kind of a rank for the most frequent items in a specific hierarchy. I will explain better why we choose also to explore the hierarchical heavy eaters. Is somehow related with the problem of the SIM farms, because you can imagine that when we have a kind of a box with maybe 100 SIM cards, we can have a kind of specific range of numbers. So we have a kind of a hierarchical range on our numbers. So we can explore better this algorithm. So we want to signal alarms when we have large numbers of phone calls. So in this specific case, we can use the heavy eaters approach. When we have the bursts of activity, so again, we can use the heavy eaters. When we have calling too many numbers, we have the hierarchical heavy eaters, but we also have another approach that we explored also, which is the hyperlog. We are counting the number of examples that we have on the data set to predict which are the numbers that have a strange behavior. For our work, we received two data sets from a specific telecom company, which I cannot say the name of this company. And you can see that we have 3 months of data for dataset 1 and 1 single month for dataset 2. In both cases, you can see that we have, in the first case, 83 million examples of data of calls, and the second one is 32 million. So there are a lot of examples that we need to read in the fastest way possible to detect our possible fraudsters that we have in our network. So starting by the heavy hitters, so we want to see which are the origin numbers that are making calls for several destinations. So our strategy is to look into the origin of the calls. Using the lossy count algorithm, we can approximate this count of frequent items or frequent callers. So the lossy count algorithm can be described by a huge stream of events, which in our case are calls, and each box or each caller here is a different user making a call. So in this specific algorithm, we split the data stream in different windows. So in this example, we split the stream in 3 different windows. And the next step is try to count the number of times that each caller appears on this window. We do that several times across all the data stream, but at each time that we move from one window to the next one, we need to remove a single example for each caller that we have on this historical data. So we are counting and removing at least one example per caller. This algorithm, of course, is described by this pseudocode. And on the right side, or the blue side, we have our proposal. In our case, we decided to explore the forgetting factors. Why we want to explore forgetting? Because forgetting allows us to see the most recent events on the stream. So let me show you a picture which is maybe very useful to understand. You can see on these two pictures here on different data sets that the normal or the original lossy count algorithm, we can only understand the most well-known callers on the data. So this blue line is the person that are making more calls on the data. This is not a very useful information. So using the forgetting factors to highlight the most recent events, we can observe different and more interesting patterns on the data. You can see on these two pictures, let's go back. In this picture, you can only see the most well-known callers or that are making more calls on the data. But looking only for the most recent events, we can see one burst of calls, some repetition here. On the second data set, we have a different pattern. You can see from dataset 1 to dataset 2, which are gated on different time spans on time, that the burst of calls are different. Why? Because the fraudsters are learning like us. We are learning to catch them, and they are learning how to avoid our techniques. So they are trying to reduce the number of calls to avoid these peaks of number of calls on dataset 1. So we make some we try to understand how this how this forgetting parameter can have an impact on the data. So we tried several combinations for this forgetting parameter, and we understand that with higher numbers of forgetting, we can have a small amount of users that have maybe some strange behavior on the data. Of course, our goal is also to improve the performance of the lossy count algorithm. the normal or the original algorithm, we can at least process a kind of 9,000 examples per second. We have at least 75 megabytes of memory used to store all these 83 million examples. But using our strategy with our fast forgetting strategy, we can reduce a lot the memory used. So our structure is very light, and we increased a little bit the speed up of reading the examples and processing the counting of the colors. Of course, we gave these examples to a small team of experts to identify which are the most relevant numbers that we capture using our heavy eater with forgetting strategy. So they identified that on dataset 1, we capture at least 4 correct fraudsters. So we have a burst of activity on this green one. We have the repetition, like I mentioned on the last slide, and we have a kind of a mirror. So we can see on this picture that the fraudsters are trying to split the amount of calls to avoid this kind of peaks of bursts of activity. On the second data set, we can see a different pattern. So the burst is much smaller when compared with the first data set that we have. We have the same kind of repetition on the call. So this fraudster is not learning so much about this field. And we have some mirrors or repetitions that we have separated by several days. So maybe they are making some calls this week, they stop a little bit, and then they return to make some calls after a while. These mirror repetitions are made inside of their own country. So if we are talking about maybe Spain, these two numbers are located at the country Spain. Of course, we use data from this other country. So our contributions for this work can be looked to the application level. So we can in real time identify several abnormal behaviors on original numbers. And at the methodological level, we extended the lossy counting algorithm with a forgetting technique, which allow us to detect abnormal behaviors with in more fast than the original lossy counting algorithm. So in terms of achievements, looking only for this heavy eater algorithm, our strategy allow us to detect the most recent items with abnormal behaviors, of course. The results shows that we improved the detection of these items, and of course the forgetting allow us to compute more examples per second. We can reduce the memory used for computing this data stream, and if we look to the data that the experts looked, we can capture some fraudsters making some frauds. So the second work that we explored is the hierarchical heavy eaters. So of course, I needed to anonymize all the phone numbers that I have on dataset and on presentation, but we can understand that we have a kind of a country code on the number. We have a sub-range of 5 digits, which can identify a possible region of the country, and the last 2 or 3 digits can be for the definition of the number of the client. So we have a kind of hierarchical structure here on these numbers. It's logical to explore the hierarchical aviators. We made a small extension of this algorithm using this fast forgetting mechanism to improve the speed of identifying abnormal behaviors. This is a picture of a sim farm that I told you on the beginning of the presentation. This kind of box can have a lot of SIM cards making calls, and this is a huge problem because we can have several ranges of numbers doing or splitting the number of calls and avoiding the burst of calls that we are trying to capture. So using the hierarchical aviators and looking only for the country code, we can identify, for example, that on dataset 1, on the specific country called IV, we have a specific number that are making a lot of number of calls. And looking for example, for that dataset 2, we have different countries, country codes with specific numbers doing these calls. Of course, we tried different variations with using the original numbers and destination numbers, where I call it A number and B number. And we can identify which are the numbers that are making more calls. So in this specific case, dataset 1 is making a lot of calls for these three numbers, which can be, in principle, a kind of gateways for this fraudster to spread the calls for Europe. And on the second dataset, we have the same pattern. So on this table here, we can see that in some specific original A numbers, we have a lot of calls, 26,000 calls, which is a lot for a unique user. In my life, I never called 26,000 times for my friends. So this is not a normal pattern on the data. We have here the top 10 numbers that we provided to the company. They checked all these numbers and they told us that we captured a lot of fraudsters making some frauds. So our second approach is try to combine the combination of A number, B number. So in this specific case, we can see that when we compare the hierarchical aviators against the aviators of the lossy count, we identified a new A number on the dataset 1, and we identified two possible A numbers that are new when compared with the aviator or the lossy count algorithm. But of course, we tried different algorithms for this problem. Hyperlog is an algorithm that counts distinct numbers on a multiset. So I decided to put here a small screenshot of a specific A number, and we can see clearly that we have a kind of repetition pattern of this user. So maybe this guy is a fraudster making calls. It's very strange to have a kind of a mean of 2,000 calls per day, which is too much. And finally, we have a different strategy. Let me go back to the picture that I have here on the beginning. Like I said, we have the mirror type of frauds. And on this specific type, we are assuming that we have this kind of hardware. So we have several SIM cards splitting the amount of calls to avoid our algorithms. But we found that we have a specific group of fraudsters that are very smart. Why? Because they spread their SIM cards by different countries. Which I mean is that we can have this dark line, for example, on Italy, and the orange line on Spain. You know that nowadays we have this law GDPR on Europe, so it's not possible to share information about the clients between countries. So they are exploring this kind of lack of security on the laws to explore and gain more money with these type of frauds. So using this algorithm that I told you, the frequent sets, we have a person here in Porto called Geoff Webb, which is the author of this Opus Miner. This algorithm tries to identify frequent sets of A numbers in a transaction database. So we pick our data and we divide it in different intervals with different durations, of course, of 1, of 5, and 10 minutes. And we try to identify which are the combination of numbers that are making calls, or that they have the same pattern at the same moment on a specific country. And looking to this this slide, we can see that, for example, looking for dataset 1, we have different countries. You can remember that the first two letters are the country code. We have different countries with a higher number of occurrences together at the same time, and we have a huge list of combinations. And at the beginning, me and Professor João Gama, we are thinking this cannot be working well, because it's very strange. Have a kind of a distributed strategy to explore this mirror behavior. But when we give this data to the company, to the telecom company, they checked all these possible numbers, and they identified clearly. You can see here these pictures are from the telecom company, that on different countries we have the same pattern. So the fraudsters are exploring this gap on the GDPR law. They are trying to disperse the number of calls by several countries, avoiding the most well-known techniques like Lossy count. So they are learning how to avoid this. So in terms of conclusions, our results shows that we can, with a simple algorithm counting the number of times of a fraudster appears on the event data, we can identify anomalous behaviors. We can also improve some algorithms like Lossy count using forgetting strategies. We also have the ability to detect this kind of distributed strategy of mirror behavior that I told you and I explained you, using the frequent sets. And using the hierarchical aviators, we can also identify numbers with higher volumes of calls with a specific structure defined by the range numbers that we have. So some open issues that we are looking for on the future. Of course, the GDPR law is a problem for us, because we cannot have access to information of other telecom companies, and the fraudsters are exploring these distributed attacks. So they are spreading all the calls for several countries, and we are not get good results trying to identify. A possible solution for this is maybe federated learning, which is an hot topic nowadays. But until this moment, we are not or we don't have a good solution for this problem. So this is the 3 papers that we published together. They are explaining all the details about these techniques that we applied on this specific problem of interconnect bypass fraud. And thank you all. So I think I am now available for questions. You have here my email, so I'm completely free to answer all the questions that you have. Thank you so much.
Hi, Bruno again. Thank you for your presentation. I think it was very interesting. And
Okay, thank you.
we have a couple of questions here in the chat. And the first one is from Anna. Is there any data on the effect of this type of fraud on PT telcos?
Yes, I cannot say which is the telecom company that I use, the data that I use, but it's true. We have this fraud here in Portugal.
Next question.
No? Yeah, so I can move on to the next one. So,
okay, the impact. Can I read or you? Or okay, what is the impact of this type of fraud in other clients? Okay, one impact is the quality of the call. Maybe in some cases that you are abroad on by maybe traveling, you make a call for your mother or your father in Portugal, and the phone call is the quality is very low with a lot of noise. Maybe you are in a kind of a scheme to pick your money, and they are using VoIP networks to send your call to Portugal. The quality is the problem. The money is regarding the network companies between Portugal and the destination country, basically.
Thank you. Next question is from Hannah again. And what kind of treatment is applied to fraudster, and how are they learning back with the treatment applied?
Well, let me. I think the question or the answer for this question is that you can see that we provide to the community several papers explaining the strategies that we are using. Why? Because we want that they learn what we are doing to improve their strategies, and we can keep improving our algorithm. So it's a kind of a cat and mouse. We are trying to catch the mouse, and it's a kind of a loop, infinite loop. Otherwise, there is no explanation to publicate the algorithms and so on.
Okay, so we have another question here from Joanna. So are the data sets unbalanced for fraudulent events? And if so, how do you handle this issue?
Yes, the data sets are unbalanced for frauds. The majority of events are normal calls. Using this approximation of heavy eaters, we don't need to look to the unbalanced data or unbalanced problem. Why? Because the number of calls that the fraudsters are doing are very big when compared with the normal ones. So we can forget that problem for a while. Because a typical user can make maybe 10 calls per day, 15 calls, not 2,000 or 50,000.
Okay,
it's too much.
So maybe just for me also, so you're saying that in terms of absolute number of events, it's really a lot more from the fraudsters. In terms of events of fraud, then it's unbalanced, but because you're total fraud.
Exactly, yes.
Okay. Next question is, well, What kind of technology are you using to implement these methodologies, and what are the main challenges for deployment?
Okay, we did this work in cooperation with Do Technologies. So our part is to develop the algorithms. The implementation part will be on the company side. So we are not aware what is happening on the company, but I'm thinking that they are using cloud solutions to have these kind of algorithms running 24 hours per day.
But do
I'm
you
not sure.
provide a distributed solution already, or?
No. In our case, our side is only to develop the algorithm that can capture a kind of possible fraudster, not develop a distributed solution. They have a team working on that.
Mm-hmm. Okay, good. So I have here another one. So are your modeling approaches biased to a specific type of pattern of fraud?
Yes, our model is biased to burst of calls, basically. This is the main problem that we are trying to capture. The last one, the frequent sets, are a different kind because they are using a much smarter strategy to avoid this burst of activity.
Do you have a strategy now to move on to these pockets of clients in which your model is not as good?
Until this moment, we don't have a new strategy. We have a PhD student working on federated learning that she will explore this specific kind of problem.
Okay.
Maybe you can find on, I think is either project which have Mobilium as a partner, CMU as a partner also. She works on federated learning, so you can find easily her contact.
We will. Next question. Are fraud patterns general across countries, or do you need to fit to particular geographies?
They are general in principle. This company that gave us the data, they make some calculations, and in a different country that they operate, of course, they can recover a lot of money using this specific type of algorithms. The target, well, I can say the name of the country. On the United Kingdom, they can return a lot of money from these kind of frauds because they have a lot of Indian connections and they are losing a lot of money.
Okay, so I think we have one last question.
Okay.
So have you tried a very simple benchmark using rules or thresholds to get an idea of the increased performance using your model?
Okay. I don't have the right number to present you in terms of benchmark. One thing that we defined with Mobilium or we do technologies is that they keep a kind of a baseline and we try to beat the baseline. So our strategy beat the baseline because they, at the end of the project, told us that you can process more examples per second, you can detect faster than our approach. But of course, they are using some strategies related with rules or blacklists, like I told on the slides, which can be a baseline, of course.
Okay. I think we don't have any more questions. So thank you, Bruno, for the
Thank you.
presentation and for your time.
Thank you so much.
And thank you guys for being here. I just want to say a few more things before closing up. Okay. So don't forget our call for proposals. We really want to share your work or share anything that you are passionate about data science or related. And without further ado, I think thank you. And let's go to the network session where you have the link in the YouTube chat, and see you guys there. Thank you.
Thanks. See you in the networking session.
Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.